Hello, everyone, and welcome to today's SANS webcast, Enabling Consistent Multi-Cloud Security, Forensics, and Incident Response, sponsored by Cisco. My name is Carol Auth of SANS. Today's featured speaker is Chris McHenry, Senior Systems Engineer Manager at Cisco Workload Security. If during the webcast you have any questions for Chris, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Chris.
Thanks, Carol. Okay, let's get started. So first off, excited to be here. I hope everyone is having a great Friday so far and that I'm not getting too much in the way. Hopefully this will be interesting. Today we're going to talk about multi-cloud security specifically. I know it's a pretty long title, but I do think that it's a very relevant challenge that I've seen a lot of companies struggling with over the last several years as the application environment and landscape has shifted. We've had to oftentimes significantly accelerate some of the transformation that we're making in our approaches to securing applications. And we'll talk a little bit about some of the foundational shifts that we've seen, as well as what Cisco is doing to address those. Specifically, one of the places that we're going to focus on today is consistency, right? And we'll dive a little bit deeper into that. So we'll take a look at the agenda real quick. We'll talk a little bit about the multi-cloud security problem and some of the unique challenges that it brings to the table. Then we're going to look at some of the specific kind of places that we can refocus our security efforts in order to make an impact in this type of environment. One of the core topics that we're going to address today is looking at security from the perspective of the workload. And we'll do a couple different things. We'll define what workload means. We'll look at how that lives as a part of the application stack, and one of the what kind of impact it can have when we just shift our mindset a little bit towards thinking around where we actually apply security as a part of the application stack. From a Cisco perspective, we are going to look at some of the core products that Cisco is building and has already on the market to address some of these challenges. We're going to look at some real world examples of how we can do things like forensics and incident response in a multi-cloud environment in an infrastructure agnostic way. And then we're also going to talk about securing the cloud in general as an important component of the multi-cloud security problem. So a little bit about me before we jump in. Funny story about this picture. I need to get a new one. This was taken about 5 years ago before I had 2 kids who are now still under the age of 4. It was on a WebEx, and this was the default photo that showed up for my profile, and stepped away for a minute and heard a couple people talking about how I look a lot older on video. So, is what it is. That was very kind of people, but either way, I've been doing this for a little while. My specific focus area over the last 10 years has really been in data center design. And obviously over those last 10 years, there's been some significant transformation there. Over the last 5 years specifically, we've been looking at how do we deal with automation, and specifically how do we deal with security in the modern data center, the modern multi-cloud environment. In fact, I think the term data center is still relevant, but honestly, maybe not something that we need to think about as a first target when we're thinking about application security. And we'll look at that in a little bit more detail as a part of this. I am also an amateur coder, and that I've really enjoyed that because it helps in a lot of these areas, but also gives some perspective in terms of where some of the risks are, because there's a lot of people like me who are putting code out there who might not be professionally trained, who might not be putting it through a typical CI/CD pipeline, who might not be checking it for vulnerabilities on a regular basis, things along those lines that add additional risk into our environments. And so as security professionals, all of these things are relevant, whether it's the amateur coder that sits in your corporation and is running scripts on a regular basis that have access to the rest of your infrastructure, whether it is the contract developer that you're using to accelerate application development. We need to figure out, how do we put guardrails on this? How do we secure these types of environments? And we're going to talk about that today. So at a high level, when we talk about cloud security, this is a very broad topic, and we want to get a little bit specific about what we're going to be talking about today. Obviously, cloud has been, it's a generic term. I'm not a huge fan of generic terms. So when we think about cloud security, there's a lot of people that will talk about cloud security. I generally find that this falls into 3 buckets. So the first thing is, as we look at the cloud itself, how do we get to the cloud? How do we secure our users as they go to the cloud? And how do we implement security in the cloud for those types of use cases, right? As our users move out of the bounds of the typical 4 walls of our offices, which is even more prevalent today, we need to think about new scalable ways of implementing security in those end user environments. And so we've seen not only a shift in how we secure users as they access the cloud with traditional things like web security, but also looking at how we implement that kind of web security in the cloud with things like Secure Internet Gateway. Obviously, Cisco's made a big investment here. From a security, securing your SaaS apps perspective, again, very important as we see people move largely into software as a service environments. I think email might be one of the most prevalent examples of this, but we can look at a number of different really interesting examples. Email being a good one, looking at how we secure email in the cloud now that all of our data actually lives in someone else's data center. Email obviously has a lot of sensitive information in it, and there's some unique security requirements associated with that. You can look at things like Salesforce.com. One of the really interesting things about applications along those lines is that they often are not purely software as a service. They have hooks into our proprietary data environment. And so while these are interesting buckets, they are not always contained in and of themselves. And anytime we have a place that we are looking at implementing security against an application, we need to be considering how an attacker could potentially leverage one of those components to pivot into another part of the environment. And what we're going to be spending most of our time on today is how do we secure your apps? And it's not just things that you develop. This is also things that, really anything that you would have at one point in time deployed in your data center. That can be apps that you develop. That can be apps that you partially develop. In fact, I would argue that no one really develops their full application, especially in the age of open source software. Everything's running on a platform. Most people are using typical web servers like IIS or Apache or Nginx, things along those lines. So there's even in scenarios where you have largely control of the code itself, you rarely have full control over it. And the fact that it's deployed in an environment that oftentimes has direct access to the rest of your network obviously has some increased risks associated with this. And this is where we're going to be spending most of our time. So we're talking about those applications that you own, that you deploy, whether they live in your data center or whether they live in a public cloud. So over time, obviously, this environment has changed. One of the big challenges that we see now is that we talk a lot about deperimeterization with end users, but there's actually also oftentimes been a deperimeterization with the applications themselves. Applications can run anywhere. A couple of years ago, I was working with a financial institution, and they were on the cusp of kind of transforming their approach towards workload security. And the first application that they wanted to implement security against, part of that application was running in Kubernetes and containers in Amazon Web Services. And the other part of that application was running on AIX in an internal data center, right? And so even when we think about applications, they oftentimes are hybrid, especially in organizations that are not brand new, right? We have technology debt. We've been running applications for 20 or 30 years that we're building on, or sometimes even more, which we'll talk a little bit about, that we're building off of. As applications have become more modernized, they also become more dynamic. And this is a really interesting part of some of the security challenges that we see. This is not necessarily unique to the multi-cloud, but one of the things that cloud in general as a conversation has brought is an increased focus on automation. So as we look at modern applications, so we look at things like containerized applications, the ability for an application to auto scale, to dynamically change, to update its code on a semi-regular basis. We're not talking about those monolithic, I'm gonna upgrade it once every 2-year kind of applications anymore. They are constantly changing. So how does that impact the security professional? Well, we'll just look at a very basic example. In a traditional environment, you probably have firewalls that sit at the front of your data centers. And if an application owner needs to make an adjustment to their application, they are going to probably need to add a firewall rule. And they submit a ticket, that ticket goes through a change request process, it gets implemented in the firewall, it takes a couple weeks. Well, let's look at a containerized environment instead, where these containers can dynamically change. They get re-provisioned. Every time they get re-provisioned, they get a new IP address. So if the firewall is configured to only allow certain containers in, it is actually impossible for me to apply the same kind of security because I can't go through that change request process. It takes seconds to spin up and adjust the characteristics of the application itself that are ultimately implemented and enforced in a traditional firewall. So big change here as well. And then obviously, whatever we're doing here, we need to be able to have it customized because everybody's application environment is unique. And these are pretty significant challenges, right? So that multi-cloud scenario where we're running anywhere, that automation that's necessary, again, very interesting. And then the uniqueness, not only of your environment, but of workloads themselves, and we'll talk a little bit about this. There's actually a lot of opportunity here for us to transition our thinking, and we'll talk a little bit about what that looks like. Before we get there, I think it's important to understand kind of the base level of how applications are actually deployed, because when we think about what we do as security professionals, time is not an infinite resource. Money is not an infinite resource either. And so we need to figure out what are the optimal ways for us to apply security, where we can get the best coverage possible, where we can implement the necessary security, whether that's compliance oriented or risk oriented. And to do that, we need to understand where we can even apply security in the first place. So the traditional place to do this, when we look at how an application is built out, there's generally 3 different layers that we see that we can target from a security perspective. Every application is always going to be running on infrastructure. There's kind of that that adage, not age old, right? The cloud is kind of new, but that adage that the cloud is really just someone else's computer, right? I mean, that is absolutely true. You cannot run an application without a computer living somewhere. Even when we get into some of these modern code development type of scenarios with function as a service and Lambda and Knative and all of that kind of stuff, it is running on a computer, on an operating system. And that's and ultimately there's code that's supporting that, right, at the very top layer. So historically, we want to be able to optimize the investment that we make from a security perspective. And when we look at the traditional data center, this bottom layer here, the infrastructure layer here, there's been significant focus on standardization. And standardization is really helpful in these types of scenarios. One of the reasons we focused on standardization is because it makes automation a lot easier. Virtualization has helped that as well. If you think about some of the real incentives early on around virtualizing compute, and then we see a lot of those similar incentives when we've moved into storage virtualization and network virtualization. Automation is really the big driver there. But that standardization also allows us to apply security in a very standardized methodology. Historically, one of the things that we've done in data centers is, we've virtualized pretty much everything, although network security, I would argue, still relatively appliance-based. I still see a lot of companies making investments in tap span networks and IDS appliances, obviously in NGFWs, and those end up being kind of like choke points for us, right? But that's doable in an environment where we have ruthless standardization. If we look up the stack, as we go up, and we look at this in the context of a traditional data center, as we go further up the stack, there's less and less standardization. The application layer really being one of those most diverse layers, right? There's multiple different languages. Not only are we coding in multiple different languages, we might not own the code. There's different platforms here as well that are an important part of that. So I may be executing Java code, but I don't own the code for the Java virtual machine. There could be a vulnerability there. All of that is an application as a whole that's running on top of the workload layer. So it's very diverse in that environment. COBOL, I put that on there specifically. If you've read the news recently, that's become a huge focus area with a lot of state and local government agencies who are dealing with an influx of requests from people in the time of COVID. And you know, it's important to understand that that environment is also, you know, in all of these scenarios, we're looking at how do we do security across both the modern and the legacy, because oftentimes they're equally important, and sometimes your most sensitive data is actually living in that legacy environment. So when we look at this particular model, this infrastructure layer has historically been our security sweet spot, because we can very consistently apply that kind of zone-based architecture that, you know, we have control over the traffic. We may not have visibility all the time. That is a pretty interesting challenge, especially when we talk about network visibility and how systems are communicating with each other. But this has been a sweet spot for us to apply security. Now, quick pivot on this, right? Even in that scenario, we know that there's things that we need to address. So the castle analogy, where we're looking at building a moat around our environment, obviously this is no longer really relevant. We know that's a significant challenge. I would argue that in the data center, we don't really have a castle methodology. We're a little bit more specific about that. We do zones. The analogy I like to use is that of a hotel, where you walk into the front door of the hotel, they check your ID, and at the door, if you've ever think about this next time you go into a hotel, they'll never tell you your room number. They'll only tell you your floor, because they don't want someone who's standing behind you in line to know what room you're staying in. So you get your ID checked, you go up to your floor, but when you get to the floor, every single door is unlocked. That is the zone-based architecture, and we know that this doesn't really stand either, which is why one of the big focuses over the last several years in terms of data center security has been implementing microsegmentation, right, or application segmentation, pushing zero trust policy closer to the application. There's a real interesting book by a guy named Andy Greenberg, who's a writer, technology writer for Wired magazine, called Sandworm, that he did on the NotPetya attack a couple years ago. And one of the statistics that he threw out was that he was talking with a large pharmaceutical company who lost 10,000 plus servers in under 10 minutes because of the lateral movement capabilities that the worm had in their environment. That is, you know, there was a zone-based infrastructure there, right? And once we get past that front door, we still need to be able to have controls, and that's even more true in the public cloud. So what has changed, right? When we go into this new architecture, that security sweet spot that used to be standardized has all of a sudden become one of the most diverse layers in this entire stack. Every time we move to a new cloud, we have new controls, and we need to figure out, how do we implement that same level of security that we had when we controlled those four walls of our own data center? How do we implement that same security again in a new cloud? And the reason the subtitle for this session is "Oh, the disparity," because the capabilities are not always the same. When you look at, you know, in general, most of the clouds have the ability to apply ingress policy, and they have the ability to give you visibility, and they have the ability to do east-west segmentation, potentially even. They have concepts of things like VRFs or VPCs or virtual networks. The terminology changes, the capabilities also change, right? And some of those nuances are really important when you look at the scalability and some of the limitations in the way that an AWS security group works. That is significantly lower than you might actually need for true zero trust application policy, right? And we have to think about how all of these different components work together. Virtual firewalls may have different capabilities in different clouds based on the limitations of each of those individual clouds. So we see a lot of companies changing their approach to this and actually building new teams to just address this individual problem. I would argue that this is moving faster than it's ever before, because that architecture around security that we had for our data center, we're seeing customers add new clouds on a semi-annual basis, right? Where last year you were in one cloud, this year you're in 3 clouds, and every time we do that, we need to add, consider what our security approach is going to be. So with that being said, right, that less standardization piece shifts a little bit, and we can start to look at, you know, is it worth as much focus on actually replicating our security approach to the way that we had done it before, or should we consider a new methodology that allows us to optimize that precious resource of time? And so it's one of the big reasons why when we look at workload security, this has become a lot more popular over the last several years. And Cisco's made huge investments in focusing on this area, because it is the new least common denominator as we see multiple different cloud environments popping up in those locations. Because even if I'm deploying something in Azure or AWS on-premise. The operating system, the component that's actually running that code, is consistent. Even when you look at things like containers or managed Kubernetes services, Kubernetes as a whole, right, focusing on multi-cloud standardization. If I can look at securing Kubernetes and the containers that Kubernetes runs, we can have consistent security across multiple different clouds. So we've made an aggressive investment in this area, and we see a lot of customers changing and shifting their focus in terms of how they replicate security across multiple environments. Now, the application layer is extremely important as well. And one of the things that we're gonna look at here is, how can we take solutions and start to implement them in a DevSecOps fashion, right? When we look at how security organizations are changing their structure. This is really important. Pushing security earlier in the development cycle, doing static code analysis, understanding vulnerability, even looking at runtime analysis in the application layer, all of that is critical. The interesting thing here, it's still a very diverse layer. And so it's difficult to go into your environment and replicate security consistently across every single piece. It's very important. But we do see that the lowest common denominator, oftentimes that's going to get us the biggest bang for our buck. And a multi-cloud environment is focusing on that workload. Another thing to note as we're going down this process, complexity is the enemy of speed here, right? So if we, where we're kind of oftentimes, I see a lot of customers spinning their wheels is that replication of the existing. If we think about this in the context of, can I refocus and look at what might be the simplest way to accomplish something, that's really valuable. And this is a perpetual fight that we have between application owners and security professionals. Is application owners, they get a lot of focus from an executive perspective. We need applications quickly, we need features quickly, we need all of these kinds of things. Security, unfortunately, sometimes slows that down. So if I can find the sweet spot here that allows the application developers to go quickly or even quicker than they were able to before, while not slowing them down, right? They moved to the cloud partly because of speed and flexibility. We need to be able to apply security, but we need to not slow it down. So we need to think about, as we're going through this, what is the simplest way for me to do this and also achieve the developer's goals? So Cisco's got to focus in a lot of these areas. Our general architecture around this is what we call application first security. And it's that whole thought process around shifting, leveling up where we look at security. It's important for us to address each of these layers still though, and we'll talk a little bit more about each of the ones. We're going to focus on workload. The product that we have to cover workload security is something called Cisco Tetration. We're going to dive a little bit more deep into that. When we look at the infrastructure layer, obviously a lot of people first focus on things like CSPM and so posture management in the cloud, consistent visibility in the cloud, looking at how do we use APIs and logs to build an agnostic layer there. That is important. We have a product called StealthWatch Cloud that fits into that category. And then the application layer, Cisco App Dynamics is a really interesting piece because while today this is mostly focused on performance monitoring, it has a lot of hooks into these deep code level things that can be really useful for security professionals. And we have a good foundation to build off of there. And then lastly, one of the crazy things about all of this stuff is that when we move to the public cloud, everything's on the internet. And I know that's not true holistically, right? If we follow best practices and we build things like VPCs that are private and we've got direct connect, we don't necessarily, even though we're in the public cloud, let those workloads access the internet without going through our control mechanisms. But the reality is there is some advantage oftentimes to using things like Elastic Load Balancer and API Gateway and things that are public. So accessing those resources, making sure that we have MFA as a part of that, but also if you look at Google's Beyond Corp Zero Trust model, one of the things that GCP has that's really interesting is this concept of an identity aware proxy, which is essentially secure access into my application environment without having to deal with secure access on every single component of the application. We acquired Duo about 1.5 years ago, and one of the people oftentimes think about Duo as just multi-factor authentication, but one of the really interesting pieces here is that Duo Beyond has the ability to do a cloud agnostic identity aware proxy, which can really help us simplify and secure access to those application environments without making major changes or distributing that among all of the individual workloads. So we're doing a lot to address how we simplify this for customers, how we make it consistent as we move across multiple different clouds. So let's dive into the workload real quick, and we'll look a little bit at what we're doing. So what is workload protection anyways, and why do I need to think about this in a little bit of a different fashion? Well, the first thing that we need to look at here is we actually look at this like an opportunity. Gartner has a new quadrant or a new market category that they put out where they're talking about, different components of a workload protection strategy. The way they generally define it is, it's time to think differently about how we protect workloads. Way too many people, because we had control over ingress and egress and that standardization, have not really put focus on unique controls for workload security. We're using typical antivirus on those workloads. We're using typical malware protection or things along those lines. Well, there's actually an opportunity here, and there's also some gaps. The different OS footprint that workloads bring mean that we need to support a broader characterization of things. The fact that we've got containers and multiple different clouds, again, new opportunities from a security perspective. And different behavior and identity means that we need different, there's different prioritizations in the way that we build a workload security solution. So the opportunity here is that workloads behave differently than end users. And this is where we're going to talk about the forensics components here. The fact that a workload, unlike an end user, is designed to do the same thing over and over and over and over again makes it a really interesting candidate for baselining. And there's actually some unique detections that we can use that allow us to look at when do things deviate from baseline, not just from like a typical process perspective, although that's very, very interesting, but also from a networking perspective. Who are they communicating with? How are they communicating in the environment? Things along those lines. From a criteria perspective, as we move closer to the application, obviously one of the things that we're talking about is agents. It's one of the ways that we can make things agnostic across the entire cloud, but agents need to be specially designed for workloads because workloads run a lot hotter than end user environments. We can't have reboots, we need low CPU utilization, things along those lines. So offloading a lot of the processing from the workload to the cloud, really important fundamental design paradigm of workload security. We also need to understand when we can't install an agent, what do we do? So purely agent-driven approaches really don't hit the mark either. There's a lot of hardened appliances that we have deployed in these environments. There's platform as a service in the cloud. And lastly, identity and context is fundamentally different for workloads. So a typical server does not have a user group in Active Directory that's meaningful and associated to what that workload is doing, especially if we're talking about containers. But what they do have is they have things like vCenter tags or CloudFormation tags that were deployed on install, Terraform tags, container, context, pod information in Kubernetes. Can we use that information to help apply and understand security policies so that when I do a forensics exercise, I know which applications are actually being affected? Integrating that novel context information that's relevant for workloads is really helpful in these processes. So to address some of these challenges, applications that run anywhere, we need to get closer to the application. For applications that change constantly, we need to significantly focus on automating security, right? And that context information is very, very helpful in that context. And for applications that are unique, while workloads are designed to do the same thing over and over again, they are very diverse. End users are unpredictable, but they also generally do the same thing all the time. They're going out to websites. They're using a lot of 4443 traffic. They may be printing things every so often. But if you look at the diversity of what workloads are doing in their environment, it's significant. So how can I baseline in the context of that diversity and be adaptive? Very, very important. So Cisco Tetration is the product that Cisco has that addresses this. And when we look at some of the fundamental design parameters here, the first thing we wanted to do was recognizing that workloads are diverse. How do we create a consistent level of security independent of workload type? We want to be infrastructure agnostic. And one of the things I like to say is it would have been foolish for us to design a product that didn't work just as well in Amazon as it does on premise. And while Cisco may historically be a networking company, you will never have control of the switches in Amazon. So we need to focus on this from the perspective of the workload. And we also need to be independent of that kind of workload. We can't be tied to a hypervisor. We can't be tied really to whether it's virtualized or containerized. We need consistency across all three of those environments. And we need that consistency whether it's in the public cloud or on-premise. So we'll talk a little bit about what we do here. There's really 4 key paradigms with Tetration that we're focusing on. The first thing that we were looking at is how do we baseline and apply policy that is more restrictive in the environment. So microsegmentation, been a very big focus here. And we want to be able to do microsegmentation and break down barriers at each part of this process. One of my colleagues, Loy Evans, did a session a couple weeks ago called Practical Design Challenges when Implementing Microsegmentation. That focused very heavily on Cisco's, on Tetration's capabilities around microsegmentation. We're not going to dive too deep into that, but that is one of the fundamental control points. And when we talk about consistency, we want to be able to do this across multiple different clouds. So one of the core features of Tetration is the multi-cloud firewall, which allows us to implement that policy consistently and as if you had a single firewall across any independent cloud. Very powerful functionality. From a baselining perspective, and we talked about some of the unique opportunities we have with workloads, understanding and getting consistent visibility into process and communications is really, really interesting. So one of the things that Tetration does foundationally is it solves the workload visibility problem. We want to be able to have insight and visibility and forensics capabilities against everything that a workload is doing, all network communication, all process behavior. And we can do that in a way that also levels up something beyond just log analysis, right? So oftentimes you can get logs that they may be inconsistent across different workload types. We have to customize them. One of the big things that we do here is we abstract behaviors in a way that allows us to consistently analyze logs or analyze behaviors independent of the workload type. So if we look at a baseline and I want to say, hey, this particular endpoint is communicating, or this particular application is communicating with an endpoint in an untrusted zone or an untrusted country, I don't need in that first pass to be able to determine, is that log coming from a container? Is that log coming from a Linux machine? Is it from a Windows machine? Is it from a VPC flow log or whatever that is? We want to make that agnostic. Leveling up process behavior, we'll talk a little bit about more of this as well, to things like, did I have a privilege escalation? Not what are the detailed logs in Windows or Linux that I need to be aware of to identify a privilege escalation, right? So there's some really cool things that we're doing here to make that unique to workloads. By the way, privilege escalation in a workload, really, really interesting. Happens a lot. But once an application is up and running, you probably won't see it very often. Baselining the way that processes execute, again, that repetitive nature gives us a lot of opportunity here. Now, we also want to do this with risk in mind. So understanding vulnerability and risk is really, really important. Can I apply segmentation policy that has an understanding of vulnerable software, whether that vulnerable software is running, what ports and protocols it's using, and how many other systems that it communicates with? Understanding that risk helps me prioritize where to start. It also gives me the ability to apply really advanced segmentation policy at the workload layer, independent of the cloud capabilities. So we're talking about moving what would traditionally be like an NGFW kind of functionality onto the workload itself. And we won't dive into too many details about the technical components of how this works. There is a Q&A. Feel free to ask questions in the Q&A and we'll address those as they go. Then the fourth category is compliance, right? So we're not just talking about we do see proactive security being more relevant in the workload environment because it's more in line with baselining, because the data sensitivity is higher there. Being able to focus on proactive, kind of locking down risk reduction, really relevant, but day 2 is really important too, that detection piece, that compliance monitoring piece. So having this consistent visibility where we're not just saying, okay, boom, I'm going into this application, baselining it, locking it down, moving on to the next one. We want to actually be able to, applications are living, breathing things. We need to be able to track compliance over time. So the first thing that we do with Tetration is we start doing a risk analysis. Now, fundamentally, the best way to do this is, again, we're talking about workload security, moving security up to the workload. Tetration has 2 components. We've got a back-end analytics engine, and then we have an agent that gets deployed on the workload across multiple different operating systems or containers. We also have agentless ways of gathering information, and we have threat intelligence that comes into the platform. Out of the box, the first thing that you're going to start getting is an understanding of risk in your environment. And you can see the different kinds of data that Tetration is natively pulling in. Out of the box, understanding of software inventory and vulnerability. We're looking at threat intelligence around process hashes and running process hashes so that we can make determinations from a policy perspective, as well as react from a forensics perspective, and we're going to look at a real-world example of that. We're looking at risk, attack surface. One of the coolest parts about this is understanding which ports and protocols are open but not necessarily in use. That is a combination of multiple different data points to understand risk. We're looking at vulnerability. We're looking at running processes. We're looking at network behavior. So that we can help make recommendations about risk reduction in those types of scenarios. And then we also have day 2 components here. So consistent risk analysis, what's really cool is when we level this up to the workload, I do not care where this workload lives. We will get consistency across every single cloud. Consistent control, this is one of the most innovative parts of the product as well, the multi-cloud firewall. How does this work, right? Again, we're moving what was traditionally a firewall control point, a choke point, that sits in this kind of consistent infrastructure. We're moving and leveling that up into the workload itself. Now, the workload oftentimes doesn't have enough overhead to do full-blown NGFW processing, so we're actually fundamentally changing the way that this works. This is not a centralized policy manager that you create a bunch of ACLs and then push it down to an individual workload. This is not group-based policy with firewalls for Windows. We've actually leveled up the intelligence so that we can assimilate these workloads into this one single global multi-cloud firewall that's capable of things like threat intelligence-based policy, vulnerability-based policy. It's capable of reacting and doing dynamic quarantining, and we genuinely do not need to care where the workloads live, so we can have consistent control without making any infrastructure changes, whether it's in a private cloud, a public cloud, or edge computing. Now, there's a lot that we're doing here to enable micro-segmentation and application-centric segmentation as well. One of the really powerful pieces of this is because we level up to the workload, the network really, to some extent, we've typically been burdened by the fact that in order to implement policy, you have to get traffic through a firewall. Now, every packet that leaves the workload or leaves the container, it can be subject to policy enforcement. So there's no more, how do I steer traffic through the firewall? Is it transparent? Is it routed? What does that look like? What are the capabilities of a security group? Everything is consistent across every single cloud. And we can do it in a progressive fashion. So let's say that you have a particular compliance need in the private cloud. I just deploy agents on the subset of systems that are built around that compliance need, and we can start to look at segmentation from the context of the application itself, because we now have full control at that workload layer, and we're not burdened to the way that the infrastructure is built in order to apply policy. So that's the multi-cloud firewall and the micro-segmentation capabilities that the product brings from a workload security perspective. Where we're going to double click down in is actually visibility. So one of the really interesting opportunities here is how do we unify visibility across multiple different clouds and actually across multiple different workload types. So obviously workload logging, there's a lot we can do from a SIEM perspective, there's a lot we can do from a SOAR perspective, but oftentimes logs are disparate across different versions of operating systems, different workload types. So one of the really interesting things that we've done with Tetration is we've leveled up these detections into a set of, essentially a detection language that monitors for a set of generic behaviors that we can then align to common tactics, techniques, and procedures. So the fundamental building blocks of like a MITRE TTP, things like privilege escalation, things like understanding and baselining process execution, shellcode execution, things along those lines, watching for access to sensitive file like /etc/password, right? Those kinds of things. We can level that up, give those capabilities into this kind of global distributed visibility engine that we can then build alerts on and use that to integrate with a SIEM or a SOAR or something, or SecureX, which is Cisco's security platform that ties all of these different components together. We do also come in with built-in rules, right? So while we give you a language that you can use, and we're going to give some examples of what that looks like to get that raw visibility and potentially analyze it in a number of different places, we can also start to create really interesting compound policies that are a part of this. So we're not going to dive into all of the details of that policy language, but we bring built-in rules MITRE being one of the components that we're targeting, to actually alert based on different MITRE attack techniques. And we give you the ability to write your own rules as well. It's not just MITRE. One of the really interesting rules that we have built in that's workload specific is built around web servers. So one of these signals that we can track is this thing called an unseen command. And we're baselining all of the shell commands that an individual system is running, and we can do that in the context of the process tree. So one of the built-in rules, it's not part of MITRE attack, but it's relevant for workloads, is if you have a known web server process, something like Apache, Nginx, IIS, things along those lines, and we see a new shell command that gets executed after that process has been up and running for a certain period of time, we're going to log it and we're going to send an alert out. Now that particular log will catch and give us forensics capabilities on every single remote code execution exploit on those web servers, right? Because we're baselining the way that the processes execute. Really interesting way of tracking workload specific TTPs. So let's look at a real world example of what this looks like. So CVE 2020-1938, GhostCat, very recent, right? Had a number of customers that had asked about this. What is GhostCat? So it seems like Apache Tomcat has been a target for a lot of exploits recently. GhostCat was a very high level vulnerability, CVE of 9.8 with the 3.x version on Tomcat 6, 7, 8, and 9. Every version of Tomcat that was available when this came out and supported was subject to this particular vulnerability. It allows remote code execution, so it is network exploitable. And a little bit more detail about what a potential IOC would look like. We understand that it's connecting to a particular port and protocol. It's part of the management plane. And so let's look at what we can do in Tetration to create a very targeted understanding and forensics exercise around GhostCat. So the first thing that we can do, remember Tetration has a concept of software inventory. We're understanding network, we know vulnerability. We can go into our entire global multi-cloud workload environment and say, I want to put extra inspection on anything that is Tomcat version 6, 7, 8, or 9 before the vulnerability had been fixed or patched. Or we also have vulnerability information. So this is a little redundant, right? Giving the versions of the software as well as understanding, hey, I just want to look for CVE 2020-1938. In this particular environment, you can quickly see across all of my cloud environments, I have one workload that's vulnerable to this. So that's interesting. I have a good understanding of exposure. We want to actually now target behavioral indicators that are associated with this vulnerability. So I can create a forensics rule inside of Tetration that's monitoring for process execution. We're calling this rule GhostCat, and very basic, we're going to say, tell me if I ever have a new command, shell command, that gets executed as a child process or where anything in the process tree is run as Tomcat, right? So very, very targeted rule built around an IOC for GhostCat. And then we are going to only trigger that rule on workloads that are vulnerable to that vulnerability. Why is this really powerful? Because as soon as an application owner patches that server, this alert will no longer trigger, which means we can significantly reduce noise. We can have more high fidelity alerts. And we all know that alert overhead is one of the biggest challenges when we look at what a SOC is trying to do. Okay, so we looked at the IOC around the state and posture of the machine. We looked at the behavior from a remote code execution perspective. Tetration is also looking at network behavior, so we can now create a rule that says, alert me if any vulnerable machines are communicating over port 8009. Now this is just one example. We can also look at open and unused ports. We can see whether Tomcat is even attached to that port or if it's attached to other ports. We could write this policy based on the ports that Tomcat is actually attached to. There's a lot of power by combining that vulnerability information with the network information. Again, this can be sent to a SIEM. You can look at this in SecureX. We can integrate this with part of a SOC. So let's look at a real world example here, consistent SecOps. How do we take all of these pieces and put them together in kind of a real exploit environment? So to demonstrate this, this is a little bit older. We put out a honeypot on AWS, opened it up to the internet. We had one of many vulnerable versions of Apache struts. Specifically, this was the one that that was popular a couple years ago in terms of some very high profile exploits. We opened it to the internet and we just kind of waited to see what happened. So part one, first thing we get, right, we get an alert almost immediately once struts has been exploited because we applied a very similar rule. Remember that out of the box rule I said about web servers and unseen commands. Couple things are showing up here, right? We talked about threat intelligence from a process hash perspective, pulling in understanding of malicious hashes. You can see this security dashboard is quickly changed. We see a high profile alert that's been triggered as well. We also can look at things like network anomaly behavior and compliance violations that are a part of this. So we want to dig a little bit deeper. When you log into Tetration, this UI is fully interactive. We can dive down in and look at, one of the where we saw network anomalies, where we saw a spike in traffic coming out. This ultimately ends up being a botnet, right? So it was attempting a DDoS, even though we had additional protections in place so that we weren't being bad internet citizens. You can quickly dive in and say, at this particular point in time, all of a sudden we saw unique behavior here. Either we're downloading additional code. We need to dive in and figure out what that looks like. So we can pivot directly out from here to the two important data points that Tetration is gathering on behavior, the network side of things and the process side of things. We see a significant spike at a particular time. Now, just for notes, right, actually Amazon sent us an alert about this as well, because all of a sudden we had a significant increase in outbound connection attempts. That alert didn't come in for about 4 hours after we initially got the alert from Tetration. So that real-time aspect of being able to sit on the workload and see what happens in real time is really powerful, also from a time to detect perspective. The other thing we can see is the order in which we can go into that process forensics piece and we can actually watch what happened on the workload. So let's double click down in here. We can see first the exploit. Right, the attacker comes in, we have Tomcat running, we can see the full process tree, the alert that got triggered here. And we can see the first thing that they do is they use a remote code execution vulnerability in Tomcat. I don't even really know what one in this scenario because we're using that generic web server workload-based rule to download a payload from this IP address over this port and protocol called mini tools. That's interesting. Let's see what they do next. Step two. Modify that downloaded payload, again, through the exact same exploit to make it executable. Step three, detonate the payload, right? So there's a lot of things that we can see here. All of a sudden, that particular binary starts forking a number of different processes. What's really powerful about this is we can see how they're obtaining persistence. We can see that they add themselves to initd, so that if I reboot the workload, it's no longer going to be executing as a child process of Tomcat. We also see what folders those binaries are actually being installed in. This is enough for us to both take action as well as clean up the exploit, which is really, really powerful. And again, we don't care where this workload lives. We can double click down again and look at that combination between process and network data. Again, I don't care what cloud this is in. Searching for all of the network traffic initiated by that mini tools process, right? And pivoting over and seeing, hey, a lot of this traffic is on port 4880. This is probably our CNC connection. Well, do we know about this CNC connection? Let's do some research. Interesting. This IP address at the time didn't have a bad reputation. Now, this is pretty common, right? I mean, it takes the time when you have a new binary, a new exploit, or a new botnet that comes online, right? The threat intelligence oftentimes is just slightly delayed, right? If it's brand new, we don't know about it yet, right? So a couple days later, this was marked as malicious, a malicious CNC, but we didn't necessarily know it at the time, and we already have enough forensics to take action against it. Process hash, we're gathering process hash as well. Again, when we first saw this, not that this wasn't a true polymorphic piece of malware, right? But it was a rebuild of a similar CNC type of system, so new process hash, right? We don't have that resource, but we know that it's doing bad behavior, and we already triggered the rule based on behavioral elements. And obviously, going down the road, a couple days later, it did get marked as bad. We would see that in Tetration as well and be able to take action against that. If you want to write a policy, a multi-cloud firewall policy that quarantines known malicious workloads that have run known malicious hashes on it, we can do that from a single control point. Again, other infections. I know the binary, I know the hash, I know the execution path, I know a lot of different things that I can then search through my global cloud inventory, cloud workload inventory, to understand whether we have additional infections in place. So combining a lot of different data points in a single cloud agnostic component gives us a lot of power in these forensics exercises without really having to pivot between a lot of different user interfaces. Again, you can see here added to system D after we reboot the particular machine, still establish persistence. Again, the nice thing about this, right, looking at this full process tree and understanding where mini tools is that I have enough information to go clean this up. We can also apply targeted control. So this is an example of a multi-cloud firewall policy attached to that binary hash, where we're quarantining anything that's been infected by mini tools from talking to anybody else. Now, this wasn't the only exploit. We only had this out for about a week, and even though we didn't have a DNS name and we didn't really call attention to it, we had a couple different exploits, a couple different attackers on this single machine. We're going to take a look at this from a slightly different path. So while we were looking at that, the first indicator for the last exploit was that process execution. In this scenario, we didn't catch that process execution for one reason or another, but what we did see was we started to look at this particular workload, primarily serving over port 80. All of a sudden, we see new connections over a couple different TCP ports that we've never seen before. So we can start to dive deeper in. We can get alerts on this, right? One of the things that Tetration does is it can also baseline network behavior, network policy, who's talking to who, what ports and protocols are normal. We can use that to lock down those endpoints with the multi-cloud firewall, or we can use that to actually alert based on deviations. So in this scenario, we see a policy compliance alert that says, here's 3 more IP addresses that we're seeing communicate over ports and protocols that we've never seen before. And we can dive down a little bit deeper. So when we look at these individual records, you can start to see, oh, we have a new connection every minute. That's an interesting behavior. That looks like a call home. We also can see that the process that's actually executing that new connection is curl-s HTTP downloading this particular payload. So we can go back in, and when we're going to do a little bit more research, it turns out that their persistence for this particular malware was a cron job that executed a consistent pipe to bash download of a particular binary, right? Again, unifying all of this information in terms of being able to have a threat response exercise. And then executing this particular traffic, we can look at the other port that was of interest. And in this scenario, we can see in the entire command line string, not just the binary that's being executed. This is running this binary, and it's communicating out to monerohash.com. We got our environment. We have a crypto miner. Again, we've done good investigation. We can understand the scope of the impact of this particular exploit, what other workloads they got involved in. We also have enough information to go in and clean it up. And again, consistency is key here. This works independent of the infrastructure because we're doing it at the workload itself. Again, we talked about persistence here. We now have a cron job that's being executed to establish persistence. So Tetration, how do we deploy this? It's very, very simple. There's actually a couple different consumption models. The vast majority of our customers use software as a service. That allows it so that we can take all of that intelligence that we talked about, all the threat intelligence, everything that runs in the cloud, and it's just a lightweight agent that gets deployed on the workload itself, whether that's part of the build process, whether that's using config management. We don't really care where the workload lives, as long as it can call home to the back end, whether that lives on premise or whether that lives in the cloud. We can deploy consistent workload security policy across any environment. Okay, so that's workload security. We're going to wrap up with just a couple more comments, right? Because we talk a lot about workload. There is no silver bullet in security. One of the questions that I typically get is, okay, I moved to the cloud. Wait, whoa, my out-of-band management network is now exposed to the internet. That's a big concern, right? If you think about that, right? When I moved to AWS, everything that used to be private, the network config, all this other kind of stuff, now has direct public access to the internet. So things like identity and access management, critical components of this. Exposure with cloud native controls, critical component to this. Hey, S3 connected to the internet. This is a critical object store. How do I make sure that I restrict access to that? Whether that's network access using cloud native controls, whether that's IAM access, all of these things are really important. So in addition to looking at the workload layer, which can be kind of a cross-functional foundational element about this. Oh, and what about PaaS, right? What if I can't install an agent? Now, there's a couple of interesting things here with PaaS. You can obviously use cloud native APIs to do this. We do also see a lot of this driving towards standardization as well. So even with things like function as a service, you look at Kubernetes being a unifying force from a workload perspective across multiple different clouds. Things like Knative, which is essentially function as a service for Kubernetes, we see that gaining a lot of popularity as well, Even when you look at managed container services in the clouds, the most popular ones are when they're managing Kubernetes, right? So there is consistency even in these environments, which allows us to really get a big bang for our buck by looking at the workload. But there's always going to be scenarios where you won't be able to install an agent. And so from a proactive perspective and a reactive perspective, looking at how we unify that infrastructure layer is really important as well. So proactively typically falls into the category of cloud security posture management. Both of these scenarios are designed to abstract the APIs across multiple clouds so that we still have that consistent experience, both from a proactive risk reduction perspective and a reactive detection perspective. Abstracting logs, looking at the difference between flow logs in Azure and flow logs in AWS so that I just get a consistent set of results, consistent set of alerts, consistent analysis, things along those lines, along both different sides of the kill chain, proactive, decreasing the risk, and the detect and the respond. On the detect and respond side, there's some really cool stuff that we're doing here with regards to multi-cloud agnostic intrusion detection. Generally, this falls in when we're looking at Cisco's application first security architecture into our product StealthWatch Cloud, right? So again, when we look at consistency is extremely important in terms of optimizing our time to respond to threats. StealthWatch Cloud does exactly that. Cloud-based, we connect to the APIs, we look at the logs that we're pulling from each of, and the native telemetry that we're pulling from each of the different environments to do both CSPM functionality and multi-cloud IDS functionality. And we're not going to go into too much detail here, but we do believe that this is a really important part of that stack as well. Again, the core focus here is how do we not rethink the way that we do security every time we add a new cloud? So being able to abstract that into a single detection platform is extremely powerful, allows us to optimize our time, and allows us to not slow down the developers. So in summary, we have a new world in applications, right? And there's a lot of real world challenges that we're struggling with from a security perspective here. We have limited time, limited resources. The deperimeterization is not just with end users, it's also with applications. And we need to figure out how can we optimize our time, reduce our time to detect, improve our proactive security posture on the application side. When our applications can run anywhere, they're constantly changing, and they're unique to every single customer environment. And we're doing that by leveling up this process, right? So looking at how can we abstract and secure the cloud itself, refocusing on that least common denominator, which is now the workload, and implementing significantly more effective security there. And then looking at how do we secure the application itself with things like DevOps, shifting left in the security in the security process, static code analysis, vulnerability assessment, all of those different kinds of things. That's what we're doing with Cisco's application for security. A couple different products that are a part of that, keying in on these three different core components. And ultimately, we think that when we start to think a little bit differently about moving that security up the stack, we can achieve that sweet spot, which is how do we implement better security where our data lives at the application without slowing the developer or slowing the business or slowing the end user. So with that, we are right on time. I want to thank everybody for their time today. It looks like we do have one question. So the question is, understanding that every day a new vulnerability appears, do we have to create rules for each one or just the technologies we use? Yeah, great question. No, you do not have to create rules for each of the vulnerabilities. That's one of the reasons why we look at some of those generic behavioral approaches, but we also are looking at it from a targeted perspective. So the example that I used with GhostCat is really about how do we augment a vulnerability management practice, but we could also be really generic about this and say, I want to send an alert attached to that web server, but I only want to send that alert anytime I see a CVSS level 10 that has a network exploitable mechanism to it, right? And has one of these three web server processes running, right? So we can be very specific, we can generalize that a little bit more. In that scenario, I'm looking at, and the one I showed, we're looking at a specific CVE, but we also have a kind of a more well-rounded understanding of some of the NIST characteristics that are applied to CVEs, and you can generalize those rule sets so that we have essentially a single detect mechanism there. How can we approach a new attack vector? Yeah, so the big piece here is like if we're looking at 0 days, So the big piece here, again, is that behavioral piece. So again, if we go back and we look at actually both of the examples that I showed, the rule that triggered there was actually really just targeting shellcode execution, right? So we're baselining the way that the web server works. And that's actually a lot of what Tetration does in that scenario, is baseline the network connections, the data transfer for those network connections, the process execution, things along those lines, so that we can start to create, so that deviations from that behavior are much more interesting, right? So in both of those scenarios that I showed, the actual detection that we used was not targeted for a particular exploit. I used that exploit, we call out the exploits because it helps, I think, understand as we're going through the forensics exercise what's actually going on there. But the detection and the alert that was associated with that was actually a generic code execution, like, hey, I saw new shell code executed that had actually we were a little bit more specific about it in the struts exploit example, that had a known pattern, string pattern that included a download. So we were looking at curls, wgets, those kinds of things, right? So very high fidelity behavioral oriented alert. That actually would catch 0 days as well in that scenario, because we're baselining the process execution and we're looking for payload delivery. So that's all the questions. Again, thanks for everybody's time. I'll pass it back to Carol.
All right, thank you so much, Chris, for your great presentation, and to Cisco for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.